Hello, I'm Mrs. Neill, and this is lesson number 12, CPCTC. What is CPCTC? Well, what we do is we learn to prove triangles are congruent by one of these 5 theorems. If we had 2 triangles, we could prove that they're both congruent to each other either by using SSS, SAS, ASA, AAS, or HL. So what we're doing today, we're still proving that triangles are congruent to each other, but then we're taking it one step further and we're using CPCTC. Note that each triangle has 3 sides and 3 angles. So each triangle actually has 6 parts to it. It's got 3 sides and 3 angles. With SSS, SAS, ASA, AAS, and HL, you know how to use 3 parts of a triangle to show that the triangles are congruent. Now HL, you just have the hypotenuse and leg, but the third part is knowing that it's a right angle for the right triangle. So you know that you only need 3 parts of the triangle to prove that they're congruent to each other. But what we said just a minute ago, a triangle has 6 different parts. Let's keep going. Once you have triangles congruent, you can make conclusions about their parts because by definition, corresponding parts of congruent triangles are congruent. So you can abbreviate this as CPCTC. So what I'm saying here is that corresponding parts of congruent triangles are congruent. Even though we used only side, 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 for example, to prove that 2 triangles are congruent, because of CPCTC, all the corresponding parts, meaning all the angles, are going to be congruent also. When triangles are proven congruent, all other pairs of corresponding sides and angles are now congruent. So with CPCTC, all the 3 sides, you can say they're congruent, and all the corresponding angles are going to be congruent also. So how do we do this? How do we use CPCTC? Okay, first you need to prove that 2 triangles are congruent. Then you're going to use CPCTC to prove that the triangle's corresponding parts are congruent. Okay, let me go over that again. First, you're going to need to prove that 2 triangles are congruent. Let's stop right there. I can prove that they're congruent through either one of these 5 theorems. I can use this one, this one, this one, this one, or this one. You have to first prove that they're congruent to each other by one of these 5 theorems. Then you can use your corresponding parts of congruent triangles are congruent to prove that the triangle's corresponding parts are congruent. So the best way to explain this further is let's just do a couple of examples. Okay, I have a proof right here, and we're going to work this. I am giving these 2 triangles right here, and here's my statements, and we're going to fill in the reason section of that together right now. Okay, so C is the midpoint. Midpoint means middle of line segment BD, so it's the middle right here, so I know that that's congruent to that. And what does that give me there? Those are 2 sides. I'm writing some notes first before I start filling all this out. And C is the midpoint of AE, which is right here. So I know that these two sides right here. So I have another side right there. So right now, I've got SS. Look right here and see what I have. What's my choices that I can use now? I have two sides. Okay, remember the bow tie. This looks like a bow tie. So what's going to be congruent when you see a bow tie? When two angles cross each other, remember, what are they going to be? They're going to be vertical. Because look right here, 1 and 2 are vertical angles. So now I've got an angle in there. I'm going to cover this up. So what theorem is this? Side, included angle, and then side. Side, angle, side. Right there. So I'm going to use SAS to prove that they're congruent. But look at what my proof is asking me. My proof line is saying A and E are congruent. Okay, that's not part of my SAS. So what I have to do is once I have the triangles are congruent, I can make conclusions about their parts. Because by the definition, corresponding parts of congruent triangles are congruent. So I need to prove that these two triangles are congruent, and I'm going to use SAS. Now I'm going to say any corresponding part, anything that's left over, I can prove that that's congruent too. So let's start on this reason part of our proof. C is the midpoint of BD and AE, and that's given. If you notice, it's a reproduction of this line right here. AC is congruent to EC, and DC is congruent to BC. And that's definition of midpoint. Okay, now angle 1 is congruent to angle 2. What did we say just a minute ago? Vertical. And I'm going to abbreviate here. Vertical angles are congruent. Now I can say these two triangles are congruent to each other. And we said that that's going to be because of SAS. Now that I've proved the two triangles congruent, oh look, I've got a corresponding part. I've got angle A is congruent to angle E. Yes, I can say that they're congruent because of corresponding parts of congruent triangles are congruent. And you can abbreviate that just like I did right there because that saves you a lot of time. All right, let's go to our next example. We have one more to do. Here's another proof. I've got two triangles that are right together. And it says here that this line segment BC bisects ABD. So ABD, this angle over here. So that tells me these two angles right there are going to be congruent to each other. Bisects means cut right into two equal parts. So I'm going to write some notes. That gives me an angle. And BC bisects angle ACD over here. So 3 and 4 look like they're congruent. That gives me another angle. Okay, which one of the 5 do you think I'm going to be using right here to prove? Okay, also look, these two triangles share a common side. If I separated them, that side would be equal to itself right there. So this side right here is equal to itself. So that's an angle, an included side, and an angle right there. So I'm going to use ASA right there to prove angle, side, angle to prove that that's congruent. Okay, now let's go down here and look at our proof. The proof line says I'm going to prove that line segment BA, which is over here, is congruent to BD, way over here. Okay, we'll get to that in just a minute. But what I have to do is once you have the triangles congruent, you can make conclusions about their parts because by definition, corresponding parts of congruent triangles are congruent. So let me prove that they're congruent right now with ASA. Then I'm going to use this to finish out. So your very first line, if you notice, it's a reproduction of the top, so that's given. All right, 1 is congruent to 2, and angle 3 is congruent to angle 4. That's definition, and I'm going to abbreviate here, of angle bisector. Now, BC is congruent to itself because it's the same, it's its own side. So that's reflexive property. Go. Now I can prove the triangles are congruent to each other. Triangle ABC is congruent to triangle DBC, and that's angle, side, angle right there. Okay, now any other leftover corresponding part I can say is congruent, and they're asking for BA and BD right here, and they're congruent to each other because corresponding parts of congruent triangles are congruent. That is our lesson for today. I'm Mrs. Neill. Thank you for listening.